I'm AJ Jallo, and I'm a computer science major.
I'm Brock Pittman. I'm also a computer science major.
I'm Jaden Jordan Caldero, an electrical engineer major.
I'm Aiden Costello. I'm a computer science major. And this is how we did the design cycle with our automatic coupe door.
The project requirements for this project was that the door must be 10 inches by 12 inches. The bottom of the door must be lifted off the ground 12 inches. The door must be made of a durable material that will be viable for the outdoors. Chicken coop door must have an automatic switch, a lever, a handle, or etc. to open and close it. It must be user friendly. When the chicken coop door is closed, it should not be easily opened or damaged. It must have been creative and inventive in the construction of the machine, and it shouldn't have went over a $40 budget and been safe.
Here's an example of the types of predators we want our door to defend against.
These were our previous design ideas. As you can see on the left, it's the chicken-powered mechanism. The middle is the self-locking door, and the right is the commercial door.
Our team also had another door idea that we couldn't find a picture for that used water to fill up a counterweight attached to a pulley system to open the door. One of the reasons we decided not to choose this design is because we did not know the room we would be in and if it would be safe to use water depending on other teams' projects around us. We also could not think of a way to drain the water automatically to close the door, so we just decided to not go with this design.
So our first design for milestone 1 was to use a controller and light sensor from a Lego EV3 kit that would turn a bolt and moves the door. But we decided to not use this idea because it wouldn't meet the requirement of lifting the door off the ground. And then our second design was using a motor controlled by an Arduino to turn the yellow dowel at the top, and which would open and close the door. However, we didn't have a motor powerful enough to do this, so we moved on to our final design. We used the wood studio at the craft center to make the frame and the panel of the door, and we used motor and wiring from the engineering resource room to make the sensors and control. Some of the problems we had was we were unable to cut the grooves in the wood, so we used a crossbeam instead to hold the door panel, and then we had to use instead of using a multifunction shield which would have buttons and number display, we had to add on buttons ourselves so that we would have more digital ports. So our final product used for the pulleys, it used at the bottom of some roller skates, which allowed low resistance, and so that a counterweight could pull up the door without with only a little bit of power from the motor. And the wiring used a photoresistor, which sent input to the Arduino, which controlled the motor in time with the light.
Some of the things that worked in our favor during the tests were that they all worked well when being presented to the judges, such as the light sensor. Switches were doing their functions pretty quickly, and the door never failed to actually move from going up to down. The counterweight was very effective and did what it needed to, and the skateboard wheels, or roller skate wheels, really got us some attraction.
Things that needed improvement in the project were stuff such as the door was having an issue fully opening and closing due to lack of power. We actually got the solution for this, which was we just added another battery. We never had a crank on it for manually opening and closing the door, but we had the idea for it would have one if it had a front part to it. A few of the wires kept falling out, but we were just able to put them back in. And then the counterweight material, we just had a bag of rice, but we should have had something like with a more defined and solid shape that didn't have a chance of spilling everywhere.
So advice for first years doing this is obviously don't procrastinate, and pick a project you already have an idea for, and don't overthink it, and because you just need to have fun with it, because you won't get to do it again.
Have fun!
Yeah.
Oh yeah! Woo!